RNN is a type of neural network. What is RNN? RNN is recurrent neural networks. RNN is a type of neural network designed to handle sequential data like text, time series data, or speech. Unlike traditional neural networks, RNNs have memory. They process data step by step, remembering information from the previous steps to make better predictions. Why RNN and why not ANN? ANN are great for independent data points, but they fail to capture the relationship between sequential data. Um, Whereas RNNs, they are really good at keeping the context and making better predictions at it. Let's say if there is a sentence called the movie is not good, even though there is a word good, because there is a word not in front of good, the prediction is going to be negative. That's how RNNs are better than ANN. Let's take a small data set. We have 3 documents: movie was good, movie was bad, movie was not good. Clearly we have a word called good, and this indicates positive. Here we have a word called bad, that indicates negative. The third line is a little bit tricky, since we have not good. Not good, as humans we understand this is negative, but machine should also understand it's negative, right? So this is where ANN fails, and let's understand how RNN actually works. First I'll say how movie was good. We'll take a single neural recurring unit. Okay, so first we'll send the first word movie. Movie means we'll send the encodings of movie. What is it? We'll send 4 zeros to the neural network. Okay, so first we'll send that, and we'll get an output. We have an activation function inside it, and we get output, and this output is also fed into the neural network when verse is sent into the network. When 0 1 0 0 0, the encodings of verse is sent into the neural network, we also provide this output along with it. Okay? Since we are sending the same output in the next step, we are calling it a recurrent neural network. Now when we send verse into the input, we get another output. Let's call the another output O2. When we are sending good into the input, into the neural network, we also send output along its weight. Let us say this is WH along with good into the neural network, and this output, the prediction, is the final prediction. So this is even more detail. Let's say we are saying, we'll go with the same example, movie was good. The encodings of movie was good are this. At time step t equal to 1, we are going to send the encodings for movie into the neural network. This is one of the neurons, and this neuron will have a bias B. They also give us an output O1. This O1 with its respective weight, let's say W0, that O1 will become aggregation of this plus bias, isn't it? So this is O1. At a time t equal to 2, verse is fed as input along with O1 from good. This is the encodings of verse, and that is fed into the neuron. Since we know that this neuron has a bias B and is going to be same bias as when we are sending movie. Sorry, this is not actually good. This is actually movie. My mistake. And there will be another output O2, and it is multiplied with W0, same W0 as in time step t equal to 1, and we get a output. This is our output. If you see, this is basically the output from this, and this is the output O1 into W0 from this. Since it is memorizing the old output, we say RNN has the ability to memorize the context. Memorize context. Similarly, when good is also sent, we will send this entire thing along with good. So the O3 is going to be sigma xi wi, where xi is the encoding of good, ठीक है, of good plus a plus sigma xi wi plus b plus o2 into w naught, where xi means encoding of good, is it? ठीक है, this is how it happens. So there is one more thing. We get an output from one neuron. Let's take a neural network where we have multiple neurons in the hidden layer. So in that case, the output from one neuron is also fed into itself, and also it is also fed into the other neurons. Similarly, since the second neuron also has an output, this output is also fed into the other neurons. So sub TK, then what's the issue? There are few limitations of RNN. RNNs are not perfect. It cannot remember long-term sequences. Let's say there is a huge sentence, like a person has written a lot of good things for 100 words, let's say 1000 words, and at the last 10 words the person has written negative about the review. Then RN will say this word is negative. It is not able to preserve the context for the last 1000 positive words. That is long-term dependency is gone, and vanishing gradient. Because of RNN suffers from vanishing gradient.